Hey everyone, welcome back to CFD Simplified. In today's video, we are diving into something really exciting, SEDFOAM. Whether you are in sediment transport, particle laden flows, or multi-phase simulation, this solver is a game changer. Yes, so let's first know these 2 points about SEDFOAM. So SEDFOAM is a two-phase flow solver developed for sediment transport simulations in OpenFOAM. It couples the fluid phase with the sand particles, and then we can get the solutions. Okay, so basically that is known as two-phase Euler form. With the help of the two-phase Euler form, it solves that, and the solid particle phase Eulerian. And then it comes to the why it is powerful, in which area it is powerful. So it is powerful for modeling riverbeds, coastal floods, and sedimentation processes. Okay, so by basically my when I'm doing my Master of Technology degree from IIT Jodhpur, I worked in OpenFOAM specifically on this solver only. So my thesis is basically based on has used these SEDFOAM solver only. So in the coming videos I'll show you my work. Okay, but right now in this video my focus is to just give you the introduction of SEDFOAM and how to install it. Okay, so basically it is an OpenFOAM is an open source, so SEDFOAM is also an open source software, open source solver. So we have to just type SEDFOAM on the Google, and you can just get the first link, this sedfoam.github.io. so just click on this, and yeah, you can see that the website of the SEDFOAM is open. Here you can see many things like read about it, okay, introduction, and how it is being developed, okay, and then the tutorials, like which all tutorials are there of SEDFOAM. These are there, what are the governing equations used, the algorithm which are used. Okay, so these are the things which is being there. Okay, so we are not in this one. Okay, so we are just going to first install. So let's click on this installation page, and then we are going to install the SEDFOAM package. Okay, so first we will open our Linux. So it is open. Now we will just copy this first one. Okay, Python is already installed. If it is not installed, then please install it. Okay, and you will need fluid form. I think I have given the information regarding fluid form. If it is not, then tell me in the comments. I'll just make a video about that. So you need this fluid form for reading the data of, or the simulation of the SEDFOAM, because SEDFOAM is made, the post processing of the SEDFOAM is basically they are doing with the help of the Python. Okay, you can do it in Paraview also. That's not means it is fine, you can do it, but they have given some results. Try to give some results of the tutorials in the Python also, and if you wanted to see the Python results, you need the fluid form Python package. Okay, so kindly install it. So first we will just try to install SEDFOAM. So we'll just copy this command, and then open the terminal and paste here and press enter. Okay, so it will take some time to install. All right, the first step is this. So I'm just pausing the video here, and then when it will be completed, because it will take time, okay, then we have to open it by giving this command. Yeah, by giving this command. So cd SEDFOAM, and then this one, and it will make. So it will take some time to make it. Let us wait till it complete, and then we will continue from there. Okay, so it's the download of the module is being done. So let's we'll press ls, so you can find the SEDFOAM directory is made. So first clear the terminal, and then we will open SEDFOAM. Okay, then we have to load bash rc, So just we'll just give this command. I've copied it, and then okay, it's not working, so let me do it once again. Yes, press enter, and then we have to give all w make. Okay, yes. So what does this all w make does? It just install each and every required things to run this solver, okay, which is there. So it is a direct command. You can just give it and it will just try to install a specific solver related to the solver related, everything related to the solver it will install with that. You don't have to go and give type the commands for each and every step. Every step is there. Only type all w make, it will run that one. Okay, so yeah, so from now it will take around 15 to 20 minutes to install. So I'll again pause it. If you install it in your computer, so it will also take some time. So, okay, so I don't want to make the video longer by waiting and seeing the installation process. So you just wait. We'll just wait. Okay, I'll just pause here and then we'll continue after the installation. Okay. Okay, so the installation of the SEDFOAM is complete. So let me clear the terminal and let's go inside. So you can see a separate tutorial of the SEDFOAM is here. Okay, so we can just right now one more thing. Right now they have added forces SEDFOAM. So now we can, before when I was using the force calculation of the SEDFOAM, basically the drag force and the lift force calculation was not there in it, but they have added. So I think I'll just check whether they have added it or not. I'm just uh, uh, I think they have added. Okay, so we'll check it. We'll check about that. Okay, so let's go inside the tutorials first. Okay, so yeah, you can see LES, PY, RAS, laminar. So I'll just go into RAS. So you can see one 2D pipeline scour is there. So basically this was my work area. I worked in this one only, but will not run this because it requires minimum 16 cores to run, and I don't have that number of cores right now, access to that number of cores right now. So I will just run a little bit one. We'll just run this 1D bedload tab. Okay, so let's copy this 1D bed load tab to my home directory. Okay, it must be copied. Oh, sorry, I have just what I have done now. It must be CP. What I have just typed CD. Yeah, CP minus R 1D bed load tab home. Okay, now I think it must be copied. Yeah, it is there. Clear the terminal. Okay, so let's go inside it, and here you can see that 0 org constant system is there. So first let's run the block mesh. Okay, so the mesh is complete, and after that I think the solver must be there. So let's open the there must be there. Yeah, so this name of the solver, if you wanted to run, is SEDFOAM RBGH. Okay, this you have to type. Only typing SEDFOAM will not, it will not run. You have to type SEDFOAM RBGH. Okay, so let me first make the uh, 0 underscore org to 0. That has been copied. Now we will run our solver. Okay, it's not running. Why it's not running? Must be some, yeah, Yes, now it's running, right? Am I doing some wrong step? Oh, stop it. I was typing F small letter. Okay, set form RBGH. Yeah. Okay, do not worry about this. It will this will come could not load because when I started using setform, not much information was given. So this could not load. Dynamic code is not an error. Okay, no, don't worry about that. It will run accordingly. Okay, if some error is coming, you can just contact me, but majority of the error comes due to some solver, due to some boundary condition, wrong boundary condition setup, especially if you are using this solver in a new in a new setup. Okay, so that will be that is why the error you will face. Otherwise nothing, no such type of error is there. Due to this could not load dynamic load, because when I started using it for, I think, for the first 15 days or 16 days, I was just struggling to run this. Because why? Because on the local machine it was running, but I have to run this on the high power computing system of my college, and there it was giving many errors. Okay, running some command was there basically, and small, and due to that small and my process was killing, my solver was killing, and it was not running. Okay, so I was thinking like, okay, some error was there from my side. I've just, because at that time GPT was also not there, so I cannot ask the chat GPT the things. So that's why it was very, I was very frustrated, like how to run it. Then I just mailed to the person who has made this solver. Okay, so their mail ID has been given. You can go on the setform website, you can find it. So then when I just mailed him, so he has replied that, okay, you can just yeah, this is the thing, you just only remove that and it will start running. I just removed that and it started running. Okay, so but to know that, and I have just gone, how much deep I can go in the Linux and the OpenFOAM. I have gone. Okay, and that was the time, when majority of my good hands I got on OpenFOAM and Linux also, because I just learned many commands due to just to solve that, why it is not running. To run that on HPC, I just good hands on HPC also, because I tried every direction I can, but it was not running. So the last one was like, let's mail the and that too I don't know that, okay, I can mail him or not. So I just eventually, in the last, I was just praying to God that please help me. So I got one, like, okay, I can mail him. So I mailed him, and then he has replied me, and then when I just removed that, and it has started running. Okay, let me show you. So when I have just which and I'm talking about. So let's go inside set form, uh, set form tutorials, and here when I'll go inside RAS, so here we'll go inside pipeline scar. So you can see that all run is there. Yeah, you can see that an and is there. If you wanted to run, what does this and means? And means that process will be running, but you will not be able to see, like you are seeing it right now. Okay, if I just put and log and, okay, so you cannot see that these screen, these live running of the solver, live running of the simulation. You can do your other works and it will be running in the backwards. Okay, but if you try to run this with this and in the high power computing systems, like basically in my college, I don't know about others, but in my case, this and was killing this MPI error. This was the issue. Okay, So to just to but I don't know that what is the issue. I just I don't have words to explain how much I was frustrated and how hard I've tried to just run this, because this was the error which was not running. When I just tried to run this directly in my own PC, it was running. I just tried once. I tried to run this on HPC also, so it running. But in HPC you cannot run it directly, because it will you know it is not good to run directly the solver. You have to run it like this, okay. And in my laptop only 4 cores are there, so I cannot run it in my laptop. So because I have to run it in HPC, because without HPC I cannot work. So my professor has given me the task to run it in the HPC, but it was not running till here. No issue was there, only this one, and that this one is coming due to this hand. So but eventually in the end I just mailed and I just got the answer. And when I just applied that one, my solution is there, and I just ran that one. Okay, so let us see up to where what this control dict is there, and in the control dict file up to what is the stop time, basically end time of this bed load turb simulation. So let's go inside system and type nano control dict. Yeah, end time is 20 seconds. Okay, and how much it has written, we'll just open another terminal and go inside 1D bed loader ls. Why it is not saving? Okay, so they have not 0.26. Yeah, I mean this it takes time. Basically it takes time to uh, to okay, right now it has reached up to zero point 0.6 only, 0.26 only, and the right interval is 5. It will take time, it will take time. Okay, so let's wait. Okay, so I tried to run some other simulation also, but it is taking time. SEDFOAM, running SEDFOAM, it takes time. Okay, it is not going to, because all the basically all the, we can say, or most of the simulations are transient, not steady. Okay, you can see that current number is coming. So according to the current number, delta t is adjusting, and then the time is it is going on and on. Okay, so it will take some time to take some time, or it can take hours and hours. Okay, so what I will do, I'll just run one of the simulation of set form, and complete running. I'll just uh, keep this okay, my mouse is not working. I'll just run the simulation, so that, because I just wanted to show you some results, so I thought that okay, I can just show you right now. But I just forgot about the, I know about this 2D pipelines called that it takes time, but I just forgot that okay, others about the others time step. I've run each and every tutorial of RAS, but I just forgot the time step, basically like what is the time interval they are saving, and then I just remember right now that it will take time. Okay, like if I'll just, I have to leave this one for 5 to 6 hours. Okay, so let's keep it till here. Let's keep it till here. Okay, and I've given you the introduction, I've given you the installation step of SEDFOAM, and basically I have told you like how like why the SEDFOAM is there and how you can use it. all right. You can just go in the website also, and there we can just try to check. Let's go inside Reynolds Everest flow tutorial, and yeah, so we were trying to learn 1D bed flow tub. So basically this is the tutorial, 1D bed flow tub. So it is like the aim of this tutorial is to explain how to use the kinetic theory to model the sediment phase in turbulent bed load transport. Okay, it is based on a comparison coupled fluid DEM simulations. All right. So this is the thing they have made. You can read it. Go on the website and read it. And after that, they have just told you these steps like run this block mesh, and then they explained about the boundary condition, the physical properties, and then after that they must have run the simulation. Okay, that is the thing. When you just run the simulation, then they have given the Python script for each and every tutorial. Okay, if you go inside the let me pause it because it will take time. If you go inside the tutorial of SEDFOAM, uh, yes, so you can see one py directory is there. Okay, once you reach here, you can see that there is each and every directory is there for the each and every script is there for each. The scripts are there, Python scripts are there for each and every directory, for each and every tutorial basically. Okay, sorry for that fumble. So this is there. All right, so you can see that one plot tutorial 1D bed load clb.py mui.py. I don't know, they have made the changes, but before it was only single Python script was there for each and every this the tutorial. Okay, it keeps on upgrading, they keeps on upgrading. Okay, so that's why they must have upgraded. Second thing is there, you can see that one data is there, data directory is there. So data directory is the directory which contains the experimental results. Okay, because what they've done is like these are the experimentally it has been done. Okay, or it is someone has given the paper, so from there they have taken the data to make the comparison of the you can compare the SEDFOAM solver results and the experimental results. Okay, so that you can see that okay, this solver is working or not, is it useful, really useful or not. Okay, so this is the, you can see that this is the simulation which has been given. Okay, so like you can see that DEM set form in my case, if I'll just go to my case, this 2D pipeline scour. So that one was basically it was done experimentally it was done. Okay, so experimentally it was done. So you can see that the dotted results was of the experiment, and the line was generated by the set form solver. Okay, so this is the thing, okay, so in that data you can find only the comparison data which with which you will compare your simulation data which you have ran. Okay, so yeah, so you always have to copy that data directory. And because I don't have the simulation results right now, otherwise I must have shown you. And I'll just show you in another video. I'll just find my simulation data, and then I'll just show you how you can plot. Okay, so these data, the data directory contains, well, that is what I wanted to tell you. What data directory contains, that is what I wanted to tell you. Okay, Python script is already written. Okay, it may happen that these Python script can give you some errors. Don't worry, for removing those errors, simple step is there, ChatGPT. Okay, you just keep whatever error you will get, just copy that error and paste this Python script also. Okay, ChatGPT will rectify and give you the correct Python script, and then you can just run it. I'll just make the comparison like how ChatGPT is useful for the CFD. Okay, I have, in my case, literally I'll tell you that the error was coming. Okay, because it was written many years back, the Python script. I don't know if they have updated it or not for this covering case. And error was coming. I just go inside the Python and inside ChatGPT. So at that time the ChatGPT was introduced. So I just asked ChatGPT, and it has given me the good written me that okay, it is using that library which is in no use in Python these days. Okay, it changed it, and when I ran the Python script, it was giving the result. All right. So this is the thing, and one more thing, it may happen that you will you can get a good result than the results they have got. Okay, a good result than the results they have got. So it also may happen. Okay, so in my case it happens is like whatever the results you can see here in the 2D pipeline discovering case, you can see that the line is going like this. My line was much closer. Okay, we'll just discuss about this in the coming video. All right, so okay, let's end the video here. Okay, this is the introduction of the SEDFOAM, and this is the like how you can install the SEDFOAM. Okay, these both the things which I wanted to tell you in this video. I have not told you much details in here. Okay, I know about that. I'll explain it in the later on videos with the tutorials. Okay, so let's end here. Okay, let's end here. If you found this helpful, hit like, share it with your fellow CFDers, and subscribe to CFD Simplified. Drop your questions in the comments, and I'll catch you in the next simulation.